Welcome to this channel. We want to look at the WAEC 2022 chemistry practical titration, that is quantitative analysis. So let's look at the question. We have all burette reading should be recorded in 2 decimal place. Before we continue, don't forget to subscribe to this channel and click on the notification button. That will notify you when we drop a new video. So now, B is, we said A is a solution containing I2, which is iodine, of unknown concentration. B is a solution of sodium thiosulfate, which is this, containing 24.82 gram per dm³. So the procedure tells us to put B into the burette and titrate against 20 or 25 centimeter cube of A. Okay, actually you see that this kind of titration is kind of different, where we put B into the burette instead of A. It is called a back titration. Actually, it is a redox titration which involves iodine. So we also call it iodometric reaction. So now, using starch as an indicator, record the volume of B that completely reacts with what? With A. Repeat the procedure to obtain consistent values of B. Then tabulate your readings and determine the average volume of acid used, as you can see here in the procedure. Then we're given the what? The molar masses of what? Of the reactants. Yeah, of the reactant. So now let's move to the second question. The continuation of the question. So looking at this is the equation of the reaction. We have I2 plus 2S2O3 2 minus going into 2I minus plus S4O6 2 minus. So that is actually the reaction, and we can see their number of moles is here. So we have the number of moles. We are told that A is iodine, so the number of moles of A is equal to 1, and number of moles of B, which is thiosulfate, is what? Is 2. So we can see that from this equation. Now, from your result, determine, and the information provided, determine concentration of B in mole per dm³, concentration of A in mole per dm³, concentration of A in gram per dm³, and at the same time, amount of ion in A. So we are going to do all these after our experiment. So our experiment is basically to get our what? Our titer value. What do I mean by titer value? That is the average volume of B used in this experiment. However, when we want to make our calculation, there will be a slight change in the formula we do use, because I told you earlier that this reaction is a back titration, where we put B into the burette instead of A. So now let's go ahead for the experiment now. Okay guys, this is A in solution, that is iodine, and we have B, which is sodium thiosulfate. So, and we have our starch indicator here. So, and that's our starch indicator. This is my pipette, and I have my burette here hanged on the retor stand. Then this is my conical flask that will contain solution A. So we were told to put solution B into the burette, but before doing all this, there are some certain things you need to understand. Number one, the procedures should be followed, because putting a solution into the burette, you need to rinse the solution with that. We need to rinse the burette with the solution it's meant to contain, so as not to be diluted by the water used in rinsing the burette initially. Then you rinse the conical flask with water, so it won't contain any of the solution that is meant to be titrated or the titrant. Then at the same time, you rinse the pipette with the solution it's meant to contain. And at the same time, when filling the burette, ensure that the lower meniscus of the liquid into the burette touches the zero line, and which means you try to avoid error due to parallax. And at the same time, after filling the burette, endeavor you remove your funnel so that it won't top up the solution, the burette for you, even when it's meant to be what? Reducing at point of titration. Then those are the procedures you need to follow to obtain accurate result. So now let us go over to the experiment. Let's fill our burette with B, with solution B. Actually, I'm trying to improvise with my burette rubber, or what's it called, the tab, because I have an issue on that this period. So being all things being equal, the experiment is going to go fine. So now let's see how to fill the burette. Let me bring it down a little bit for you guys to see how it is being filled. Now, when filling your burette, ensure the conical flask is not under it, so that there won't be drop of the solution that is meant to be in the burette into the conical flask, to avoid any error in your volume or in your volume that you are meant to get. So now so after filling that into the burette, the next thing is to pipette your solution A. Pipette your solution A. Okay, even that should have been done before filling this into the burette. Okay, let's pipette. We'll top it up by the time we start the experiment. So let's pipette solution A. Okay. Now this is our solution A. This is solution A. So let us start the experiment now by titrating. And when titrating, the first color change we need to observe is yellow. And I think the solution has turned yellow now. So the next thing for us to do is to what? The next thing for us to do after observing a yellow color is to add a starch. So when adding the starch solution, you put a drop. Okay, the drop of starch solution. Let's see what happens to the solution. Good. After adding starch, we discover that the solution turns a kind of blue. Yeah, it turns blue, dark blue. So we continue the titration until we have a colorless solution. Now, so we need to keep titrating until we have a color change to colorless. Okay, it seems we are approaching that. So I think at this level I need to be doing that bit by bit to get my accurate results. So I think we are approaching 30 now. Okay, I think this color change is now just faintly. We are still on 28 point something. Okay, now I think the solution has turned colorless. So this is a colorless solution, and that has shown that the endpoint is reached. So what is the value on the endpoint? I can see 29.8. Okay, 29.8 is the endpoint. So let's record that as our final reading for the first title. So we are going for the second titration now. So this is our solution A. So now to get consistent value, we need to, okay, I think I've gotten my yellow solution now. Just immediately, not quite long. So now I need to add my starch. Then to continue the experiment, I have maybe 1 or 2 drops. Okay, good. Now after adding that, you see the color change from blue. Just make it visible. Then I continue the experiment. Okay. All right. It's trying to change the colorless now, so I'm trying to be careful at the points we reach the other time. Okay, I think the endpoint is reached as well. It has become colorless. I don't know if it is actually clear here, but maybe a reflection on the table might also cause that. But I can see that it is colorless now. So that's just like the previous one we have. I poured here. So that one is colorless solution. So if I add it now to see the color very well, you see that it's colorless. You see that it is colorless.
Yes,
so
colorless.
It has changed to colorless, and that is the end of the titration for the second title, right? So, and our value still falls within, let's say, 30. Sorry, that is 30. Let's say 30.0, 30.0 straight away. Okay, let's record that. So we are going for the last titration. However, when I did my first titration, I got 29.80. I knew that 29.80 times 2 will be almost more than 50. So what is more than 50 actually? When I wanted to do my perform my second titration was that I refilled the burette back to 0, and that is what I'm doing now as well. So since I got 30, I know 30 minus 50, I cannot get another 30 again, so I have to refill the burette back to 0, then do the third titration. So now let's refill the burette again. So we refill the burette back to 0. It is very, very convenient for us to refill back to 0 so that we can get our accurate values instead of using numbers like 4 or thereabouts. So let us refill the burette again back to 0, then we go for the last titration. Okay. Yeah. So adjusting it to 0. So now let's go for the titration. Let us pipette our A into the solution now. Alright, let's go for the last titration. That's now it goes. So I think I've seen the yellow color now. So I think mine is too quick, but you might not observe that while performing yours anyway. So now let's add the starch at this point. I'm adding my starch with a syringe, but I'm being careful to add just enough drop for it to be visible. So then I go ahead with the experiment. So now let's see. Alright, I think we are getting close now. We are still on 25. Wow, I think the color change is there. Seems to appear blue. Okay, let's still put more. Yeah, we are still within the range. Now it has changed. So we have seen the color change. Let's try to pour into this and see the difference. As you can see, it is not a colored solution. So it is colorless, as you can see. So it shows that what the titration has completed. So okay, after the experiment, this is what we got in our table. In the first title we got 29.80, and which our volume of BU is 29.80. Then in the second title we have 30.00, and in the last title we have 29.80. So we are going to determine the average volume of B used in from this table now. So how do we determine that? We know by calculation. We just go ahead and do this. That is average volume, that is VB, will now be equals to 29.80 plus 30.00 plus 29.80, all divided by 3. So by computing that now, what would I have? So the value we got for VB is approximately 29.89 centimeter cube. That is in 2 decimal place, 29.87 rather, 87, 29.87. So that is the value we got for our VB. So now we were told that from our results calculate the concentration of B in mole per dm. However, if you look at it very well, in the question we were given the mass concentration of B. Okay, from the question we were given the mass concentration of B to be 24.82. So that means mass concentration of B is equal to 24.82 gram per dm cube. Now we're going to find the concentration of B in mole per dm cube. And you know that molarity, which is that molar concentration, is equal to mass concentration over what? Molar mass. So to calculate that, we have the mass concentration, which is 24.82, divided by molar mass of sodium disulfate is 158. So let us compute that and see our answer. So we have 24.82 divided by 158. So that actually gives me the concentration of D in mole per dm cube will now be what? 0.16 mole per dm cube. So that is the concentration of B in mole per dm cube. Now we're going to find concentration of A in mole per dm cube. So to do that, don't forget that A is the solution in the conical flask. So to do that now, we use the formula CB, concentration of A rather, in mole per dm cube. Now, so we have CB, VB over CA, VA equals NB over NA. Now, this formula changes because we are talking about back titration where B is put into the burette. Okay, let's look at the formula now, CBVB. I said this formula changes because it is a back titration and we are expecting to titrate our B against A. So the formula changes this way. And we've gotten our concentration of B to be what? 0.16. So we'll put that here 0.16. And don't forget BB is our average volume of titer. So we have 29.87 all over CA, which is concentration of A, which we are looking for, that is CA. Then multiply by VA. VA is the volume of the pipette use, which is 25. All equals to NB. NB, don't forget that is the number of moles of B in solution, and that actually is 2 all over NA, which is what? 1. Then we have to compute this and cross multiply. So I'm going to have what? CA. Okay, that means I'm going to have 50 CA. Can you see that? Equals what? 0.16 times 29.87. So let us do that so that our CA will be equals to 0.16 times 29.87 divided by 50. So let's just compute that now and see the value. So we have 0.16 times 29.87 divided by 50. So that gives me Ca equals 0.095 mole per dm cube. So let's look at that very well. Mole per dm cube. So I can actually write this approximately as 0.1 mole per dm cube. That is the what? Concentration of A in mole per dm cube. So now we go to the next question, and the next question says, so we are going to look at the next question, and the next question says concentration of A in gram per dm cube. So that is so simple. So to answer the third question now, that means we are looking for the concentration of A in gram per dm cube, and we are still using the formula which says molarity, and that molarity is the concentration in mole per dm cube equals mass concentration over molar mass. So which means at the end of the day I'm going to have my molarity, which is what we just got, that's 0.1, all equals mass concentration is what we are looking for, M, all over molar mass of A, and that is 253.8. That is mass of iodine. So which means M will be equals to 0.1 times 253.8. So let us look at that now. So I'm having 25.38. So M equals 25.38 gram per dm cube. Now the last question says amount of I in A. Amount of I in A. So calculate the amount of I in A, that is question IV. The next thing for us to do is we use amount, which is number of moles, and number of moles equals concentration times volume. So now we've gotten the concentration to be 0.1, then the volume is what? Is 29.87. 29.87. So which means our answer is going to be 0.1 times 29.87. So that gives us 2.99 moles. So I'm having 2.99 moles of A. So that marks the end of the video. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.